Let's take a cup of water. There we go. This is water. And let's put actually a straw in it on an angle like this. And once the straw hits the water, now we expect it to continue going like this. But if you look from the side, it looks like it's broken. It's bending. It's going like this. What are they doing? Oh, that's yep. Yeah, that's my old stuff. Yep. So the light's going to reflect. It's going to go like this. Well, why would it reflect? Well, Snell's law, now if I draw a 90-degree angle, like right there, let me call this theta 1, and this is theta 2. Snell's law says n1 sine theta 1 is equal to n2 sine theta 2. N is actually the index of refraction, and that's a constant. For example, here we go, N. N for ice is 1.31. N for diamond is 2.42. N for water is 1.33. N for air is 1. So when you take a straw, and let's put some numbers here and see why it looks like it's bending. So this is air here, and N for air is 1. This is water here, and N for water is 1.33, I think. Where's water? 1.33. So when you take that straw and you put it there, let's say an angle of 40 degree right there. That's 30 degree or 40 degrees fine. What's going to happen is going to bend here. It's going to come out a different angle. Let's see what that angle, we'll call it theta. And the question, what is that angle? How do we figure what that angle is? Well, Snell's law says take N for air times sine that angle times sine of 40 equals, that's N for air, equals N for water times the sine of theta. Well, N for air is what? 1 times sine of 40 is equal N for water, which is 1.33 times sine theta. Can we get what sine theta is equal to? Sine of 40 sine of 40 divided by 1.33 is what? 0.560, which means theta equals the inverse sine of 0.560. And what's theta? Second sine. Oh, I got to make sure I'm in degree mode. I'm actually in radian. So let me redo it again. That's not right because I was in radian mode. Sine of 40 divided by 1.33. That number is 0.483. Is that what you got? Because I forgot. I was using the calculator last night for calc and I was using radian. So this number is 0.483. What is the inverse sine? 0.483. It's 29 degrees. So it's 29 degrees. Notice the angle. When you go from a smaller value of n to a larger value of n, it will shrink. So what happens now when you look at a fish tank? We'll go through it and see what will happen. And it has a thick, thick glass. And you watch the light go through, like there's a beam of light going through there. You shine a light going through it. Let's see what happens there. So I got a tank. It looks like this. And we have a thick glass because I want to be able to see it. So this is glass. What kind of glass we're going to use? Let's use, you want a crown glass? N for that is equal to 1.52. This is water here. N for water is 1.33. And we shine a beam at this. There we go. I take a beam of light, one of those laser beam, and I shine it. This is air. And N for air is 1. What's going to happen to that air, that beam, is going to deflect or refract. It's going to go through it, but it's going to bend. You're going from a lower value to a bigger value of N. Let's call this angle alpha. Then once it hits this one, here's a beam. Now it's going to go from a larger value of N to a lower value of N. Is going to open more. We'll call that beta. Can you see it? You're going from a small value of N to a larger value, so it's going to come closer to the normal one. Then you go from a larger value of N to a smaller, is going to open. And I want to find what alpha is and what beta. So the beam looks like bent again. If you can look at it, if you can see that beam going through the glass, it's going to look like this. Then as it goes through the wire, you're going to see opening more. So let's start with the first one, from air to glass. If you watch that beam to go from air to glass, we go 1, that's N1. Sine, I gotta give you an angle first here. What angle you want to fire the beam at? What do you want to use there to start with? Pick a number.
24.
24. Sine 24 degrees equals N for the glass, which is 1.52, sine alpha. Let's take sine 24, 0.407 equals 1.52 sine of alpha. What is sine of alpha? .268. Alpha is going to be what? The inverse sine. It's 15.5 degrees. So when it goes through the glass, that angle is going to be 15.5. Now after that, the beam is going to go from glass to water, right? So what's going to happen? Let's see what beta is. Glass, N for glass is 1.52 sine of 15.5 should equal N for water 1.33 sine beta. Take the sine of 1.52 times sine of 15.5 times 1.52 is 0.407 equals 1.33 sine beta divided by 1.33. Sine beta equals what? 0.306. Beta is going to be the inverse sine of 0.306. (17.8 degrees). Notice you enter 24, you go through the glass of 15.5 degrees, you go through the other one at 17.8 degrees. This is actually what happens too when you go, just to give you an idea, sometimes you throw something in the pool, especially this time of the year, you go swimming and you playing a game, you toss it in the pool, it doesn't look that deep. Or you're in the ocean there and you see a rock there, you go to grab it, it's not really there. Because what you're looking at, if this is the water, and let's say you drop, like somebody dropped, I don't know, goggles there. And you go to pick up the goggles. The goggles are sitting on the bottom of that water right there. There's where the goggle's sitting. So when your eyes look at them, this is what happens to your eye. The beam. The beam comes in like this. It hits the water and deflects or refract. It goes this way. What you and I actually see, to us, this is what happens. It looks like that line, your vision did not change and continues in that direction. So to us, that goggle looks right there. That's where the goggle looks. That's why the object always looks not as deep. Because we don't see that beam coming out of our eyes and move in that direction. But that's what happened to that beam. The sun hits this one. The reflection of this goes through the water. Then when it hits the water, it comes out of the water to air. It goes from high value of N to a lower. It bends even more. So that's where your eye is. If this is your eye here, that's what you're seeing. But to us, it looks like that's where the object is. That's why they say object in water always look less. It's not as deep as you think. You go to give them and you keep swimming up. I'm not there. You think it's right there, but no. It's 3-4 feet deeper, 10 feet deeper. You know. But for that reason, N1 sine theta 1 equals N2 sine theta 2. Now, there's something called internal reflection here. And what internal reflection is, let's say that we want to spy on, in the service, a Navy SEAL. This is the Navy SEAL down here, swimming in the water. And they're trying to check, actually, there's people here, we're trying to spy on them. We want to make sure nothing is going on. So the question is, at what angle? what's this angle called theta, that when the beam leaves the water, comes through air, comes out at 90 degrees. Comes out horizontal like this. So this is 90 degrees. That's what internal reflection is. Because if it's with the ground, they're not going to see us. That's 90 degrees. Anything greater than that is going to reflect back into the water. So we're looking for that critical value that when the beam comes out, it's horizontal with the ground. Makes a 90-degree angle. Well, if you apply, if this is N1 and this is N2, it doesn't have to be air and water, we can say N1 sine theta 1. Well, what's theta 1 here? What's that angle? 90 degrees, right? Equals N2 sine theta 2. What is sine 90 degrees? Isn't that a 1? So N1 equals N2 times sine of theta 2. And if you know N1 and N2, if you divide them, so you want theta 2 to be the inverse sine of N1 over N2. And that will give you internal reflection, where the angle or the reflection comes out even with the horizontal, straight in the x direction. So it's really the same equation, it just looks like this. We took sine theta 1 out. And the reason we took sine theta 1, because sine of 90 degrees is 1. So that's the only difference between them. If the angle is larger than that, so if we're dealing with this example, water versus air, we know for air n equals 1, for water is 1.33. So if you plug them in here, you have 1 equals 1.33 sine theta. So sine theta equals what? 1 divided by 0.75, which means theta is the inverse sine of 0.75, and that's 48.8 degrees. So if you if you're looking at 48 degrees, if you're looking up there in that direction, your reflection will come that way, horizontal. If the angle exceeds 48, it's 49 degrees, it's going to go back into the water, you'll never see anything. So that's what internal reflection is.